Thank you very much for the opportunity of addressing this seminar. I'm a geologist, but we're not going to just stick to straight geology. I'll have some elements of what Jason talked about earlier, which is markets. So I'm going to look at lithium and natural graphite, a global overview, markets, production trends, and exploration activities. And how do we make this thing happen? Sorry. I'm a consultant geologist with CSA Global in Perth, a company that's been around for more than 30 years. We have a global presence, as shown on that map. I hope you can hear me. I've picked up this winter cold and my voice isn't working too well, but and CSA has broad experience from targeting and exploration through to resource definition, estimation, mine planning, data management, and corporate activities such as due diligence for companies. To set the scene, we're going to have a quick look at markets. Where are lithium and graphite being used? Where are they produced? How much is being produced? How much more is needed? And what have explorers found? And then a couple of conclusions at the end. You've already seen some of these graphs, but I think all we need to do here is highlight, for example, in lithium, that, and this graph is 2 years out of date. As Jason pointed out, rechargeable batteries have now overtaken the ceramic and glass market. But the fact is, it's really interesting here, this market is dominated by two sectors. And what's driven the hype and excitement? As mentioned before, for lithium carbonate, a huge spike in prices and up to $22,000 according to Industrial Minerals magazine for spot prices in China. Where's it produced? Rather a busy map, but on the left there, shown in blue, continental brines, that's where they are. There's some up there, and over there in China. They're a big producer. Shown in red, these various red dots, not all in production, but they're just representative of some of the pegmatites that are used to produce lithium. And there, of course, is Greenbushes, the world leader pegmatite producer. And then lithium-rich clay and sediment shown in green. These aren't actually in production. That's the Rio Tinto project over there in Serbia. And then volcanic ashes, I've called it, which is clays like hectorite. Haven't been brought into production yet, although a lot of people are looking at them. And I know that this table looks a bit complicated. All I wanted to do was highlight here there's a lot of lithium minerals, of which there are two important ones. Spodumene is the most important. You can see down the middle there's some quite complex chemistry, and they do range in lithium content and also in density. That was just to highlight the fact that there's quite an array of different minerals we need to look at as geologists. And this is a pegmatite from Zimbabwe showing petalite, the pink mineral. It shows that it's a really coarse-grained leucocratic rock, which presents certain issues with sampling core, for example. And then just looking under the microscope, and this is one of my favorite themes, is not all industrial minerals are created equal, not all lithium deposits are equal, and not all graphite ones are. And if we just look at this, the dark mineral there's spodumene, there's the scale, 0.2 of a millimeter, and you can see that there's quite a complex intergrowth where a mineral called petalite has been replaced by spodumene and quartz, and clearly that could have impact on processing further down the line. This is a really interesting graph. We can see that it really started to spike total lithium production, lithium minerals, and you can see here, this is from the USGS. It includes a whole swag of different products and minerals. It really started to increase dramatically in about 2000, that I guess is related to the housing boom or the construction thing in China, as well as lithium batteries. So if we just have a look at the data that was behind that, and I do appreciate that this is a complicated looking table, but I've just highlighted here something interesting. Well over 400,000 tons of spodumene concentrate from Greenbushes, and then Chile is the other big producer. That's a lithium carbonate tonnage. So how do we actually report lithium? I've got a list at the bottom there showing lithium, lithium oxide, lithium carbonate, and those are the different things that we'll see when we read releases. Different people use different numbers. Often the market reports use lithium metal or lithium carbonate equivalent, and we just need to be aware of which ones we're looking at. Global lithium production, as Jason pointed out, dominated really by two countries, Australia and Chile. And then if we look at the percent of global production by producer, we've really only got about 4 dominant producers as well. So it's quite an interesting market from that angle. Total production 2 years ago was 160,000. It's now up to about 172. But interestingly, if we look at the brine production on the left here, percentage, it's between 3 companies really produce most of the world's lithium from brines. And then if we look at pegmatites, totally dominated by Talison with the Greenbushes deposit. So where are the lithium markets going? Again, Jason did it in a lot more detail than me, but I think this is really interesting to look at history, which Jason did mention earlier. 20,000 tons of battery lithium carbonate equivalent in 2008, increasing to 64,000 in 2014. This is information from Roskill and a company called Stormcrow. And that's just the batteries as a percentage of total lithium. It's grown from 15%, 17% to over 35%. So that tells us where we've come from. I think should give us some confidence that if things continue the same way, the market will continue to grow. Now, this is an awful table. We'll move on to something a bit more pleasant, but this is just data summarized from the Stormcrow report. And they've predicted that total lithium carbonate would grow from that 166 2 years ago to upwards of 400,000 tons of lithium carbonate equivalent. And if we really zoom into that table to what matters, rechargeable batteries from 50,000 tons, they're forecasting 200,000 tons in 2025. And if we go to the next one, one thing that's often forgotten is the glass and ceramics is still a huge thing. Although it's going to get a smaller slice of the pie, it could still grow from roughly 60,000, double up to 120,000 in the next 10 years. And I think a lot of, what's really important there is the lithium that gets used in glass manufacture, for example, smartphone screens. Lithium's used there, and we've seen growth in other areas too, where, for example, glass manufacturers may want to use lithium or add spodumene to the glass batch to reduce the melting temperature. All of these things can help with the economics of a project or increase flowability of glass fiber, for example. So we shouldn't actually forget about that market, this glass. And something that's quite interesting, I've just drawn up this graph that at the bottom shows the 50,000 tons of lithium carbonate equivalent going into batteries, and that forecast of 200,000 tons 9 years away, and it could be a lot more than that. How much spodumene concentrate do you need? You need quite a whack of concentrate. If you had 1 million tons of spodumene concentrate, you'll get about 125,000 tons of lithium carbonate equivalent, and that's assuming a 5% concentrate. So this graph, we can bear that in mind when we have a look at what the new emerging producers are going to be coming up with, certainly from pegmatite angle. And where's the lithium going to be sourced? Very complicated table. This is from Benchmark Minerals. And they do give us permission to use their tables, by the way, as long as we cite them at the bottom. So those circled in red just shows you the small number of global producers, and this whole swag of people down at the bottom here are hoping to get into production. And in fact, that table's already out of date. So there's in excess of 50 active junior explorers in the lithium space. 2 new producers, Orocobra and Galaxy. I've identified 5 emerging producers. And then there's several explorers that actually have found lithium mineralization in drill holes, which I think's a good sign. They're not just kind of saying, well, I'm near somebody and I might have something. So if we'd like to have a look here, I've included Greenbushes, seeing as it's such an elephant in the room. This is purely these explorers that have come up with resources related to lithium pegmatite or granite. And if we have a look at these resources, they add up to 936 million tons. It is skewed by the one at the bottom here from the European Metals, which is a granite-related Grisons and Waldite tin deposit. There are the grades, and if we just look at the number at the end there, these resources have got 22 million tons of contained lithium carbonate. This is just contained. Of course, once you take into account extraction, the losses during the concentration of spodumene, then the losses after it's been calcined. To produce spodumene B, there could be quite significant losses. And then emerging lithium producers. I've listed their Galaxy resources, General Mining, and then Orocobre, they've got an asterisk next to them. That's because they're actually ramping up. And I've given the production forecast. This is all available from publicly available documents, public announcements. That's the amount of spodumene concentrate that they are aiming to come into production with. That adds up to 1.2 million tons of spodumene concentrate. And just some rough assumptions suggest that's equivalent to about 150,000 tons of lithium carbonate equivalent. And if we add in Orocobre, that brings us up to 165. So these new guys could bring about as much production into play as is currently being sold globally, maybe over the next 5 years. And I haven't even looked at brines. I've just focused on the pegmatite because that's actually an area I know better than brines anyway. So, and it's important for this state. So now there's some at least 50 junior explorers, and I've just selected some, and they're in alphabetical order only, with identified hard rock lithium mineralization. They've drilled boreholes, or they're working on a project where there's historical information, and there is lithium mineralization. Ardiden, Canada, there's another Canadian one with Argonaut, then Birimian Gold, who's getting some quite nice values in Mali in West Africa, Kidman Resources in the gold fields. I'm just not sure what the mineralization is, but they've got some nice looking grades underneath their gold pit and a pegmatite. Pioneer Resources in Canada, Plymouth Minerals, mica and amblygonite in Spain, and then Prospect Resources in Zimbabwe, who've got a petalite and spodumene pegmatite project that they're working on. So these are just some that I've pulled out to illustrate that there are other guys that have got mineralization, even if they don't have mineral resources at this stage. And now graphite. I just wanted to highlight that some of the information here comes from this industrial minerals research book that I helped compile last year. This graph is slightly different from Jason's, but still shows the dominance, for example, of refractories and metallurgical applications. The metallurgical ones mainly take the amorphous graphite, which has now been substituted by anthracite, for example, in some countries. But still, you've got 60-something% in those two markets, and then the batteries there, which is hopefully the growing one. And then I've got an other sector, which includes the expandable graphite. So similar to lithium, it's a market dominated by a couple of big segments. And slightly different from Jason's earlier, I've estimated 1.2 million tons of total graphite production in 2014. Of which I've estimated flake at being 0.8 million tons a year. Now, the reason I've included flake is there's graphite that's less than 75 microns is often classified as amorphous. But I've decided to break this down that amorphous is purely metamorphosed coal, and the flake comes from graphite schist. So that's the way that I've split this market up. And then vein with 1%. Again, very interestingly, dominated by China. And if we add Brazil on, we've got about 85% of the world's graphite production from those two countries. And North Korea is an interesting one. I've picked up that quite a bit of graphite's coming from North Korea into China, up in Heilongjiang province. That was based on a visit I did there last year. So my North Korea figure's a bit higher than other ones. So where is it produced? Okay, this map came out of the graphite report. And all I wanted to do was highlight here that China is, as I mentioned, the dominant producer. We have in the eastern part of India, Sri Lanka over there, Valence, who now not producing in South Australia. Madagascar is a famous producer of big flakes. Zimbabwe graphite mine, that one down there, number 2 up there, and there are all underground graphite mines, which is quite an unusual thing, but they have very high grade, 20 to 30% graphite content. The others are all open cast. And then one big producer over there, well, they're not doing big tons at the moment, but is Imerys, the French company, and some in Mexico. Now, just a quick look at what does this graphite look like. Just to highlight again, they're not all the same. That's a vein graphite from Graphite Cropmules mine in Sri Lanka. You can see there's the graphite, nice and shiny, massive material with vein quartz. And contrast that with Flake graphite from GK's underground mine, and that was a Chinese mine I visited. Just to highlight that there's differences. And if we look under the microscope, we could see Ankuabi project in northeastern Mozambique. From Triton, you can get some really big flakes of graphite. And this mine over here on the right-hand side, the scales are about the same, 500 microns, a completely different shape. So just to keep it in the back of your mind that not all of these places are going to produce identical material, which is what the explorers have found. If we look at global graphite production from the USGS numbers, you can see it was about 100,000 tons a year up until 1950. Then it went through a number of cycles related to various GFCs that have happened. But there's a general increase from there to there of about 3% compound growth per year. And a lot of it's been related to steel, as Jason mentioned earlier, steel production and refractories. These blue and red bars here are the combined steel production in tons. And that's the graphite production shown on the right-hand side there. There's 1.2 million tons. But one interesting thing is that the graphite production has started to lag the steel, and that's largely due to graphite consumption per ton of steel decreasing as people get their plants more efficient and get refractories a bit more efficient. And just like the graph that I showed you earlier of lithium, that figure for spherical graphite that Jason had mentioned earlier, I've estimated around 30,000 tons in 2013, and then increasing to about 130 or 140,000 tons by 2025, and that probably is on the low side. That's how much spherical graphite you're actually going to need for that amount, at least 320,000 tons of spherical graphite, assuming that you get about a 40% yield. So where's this extra graphite going to come from? The same map just showing where the exploration activity has been. Lots of activity in Canada, one up in Alaska, there's been some in Russia, South Korea, a fair bit in Australia. This map was from the report from last year, so I don't have people like Renascor on there who've now got a resource. And these are only with reported resources here that are available publicly. And then if you can see the huge concentration down there in northern Mozambique and sort of mid to southern Tanzania, a whole host of companies. A whole lot of resources. We don't need to look at all the individual stuff, but they've been ranked in terms of increasing mineral resource tons. The total you come out with is over 5 billion tons at 7.7 average and 400 million tons of contained graphite. But just remember that each of these have different characteristics and are likely to serve different markets or find their own niches. And if we just look at that table graphically, this is the million tons. I had to do it on a log scale because we've got these two Mozambique projects, Syrah and Triton on the right, that really mess up the graph if you plot it on a normal scale. But the rest of them, you'll see most of these other people are running mineral resources between 10 and 100 million tons is kind of the area that a lot of them are in. And if we look at the resource grade, Talga Resources, who we probably, I think, are going to hear from later, their deposit's over 25% graphitic carbon. And then the other ones, I'd say, generally range between 5 and 15, and the open cast mines in China usually run at around 5 to 10%. That's the sort of number. And just to highlight the flake size thing, they're also different. Each of these deposits has different amounts of, if we take the extra large being the blue, large red, and then medium and green, these different deposits have different characteristics and are likely to make different products, which is why it's so difficult for these people to get into production, because it's not just a case of churning graphite out. Now, total graphite resources added since 2012, I mentioned that 5.2 billion tons of rock. Slated production, I've just selected 7 here that I think are kind of imminently in production. Syrah in Mozambique, who we've all heard about, 380,000 tons they're hoping to produce. Magnus in Tanzania, Kabaran, who's really done a good job of marketing. That's one thing he's focused on. The Kabaran company is actually securing markets. Graphics, which is IMX, have got their deposit in southern Tanzania, and so we go down here. The last one, I'm not sure of the production, but they're actually in production. How many tons? 6,000. And then the interesting thing is this accounts for about 0.8 of a million tons if they can get their act together, which is about the same as the amount of flake graphite that's being produced at present. What conclusions are there? Not all lithium deposits are created equal. Each pegmatite is individual, and this is something people do need to take cognizance of. They've got different minerals. They're going to be processed differently. Same as brines. I haven't touched on them, but different brines have different mixes of elements which make different processing necessary. Global production, roughly 165,000 tons of lithium carbonate equivalent, dominated by two sources, brines and pegmatite, dominated by 4 players, dominated by 3 countries, Australia, Chile, and China. And the markets, as with the graphite I mentioned earlier, batteries and glass or ceramics are the 2 dominant markets. And keep in mind the growth in glass, which I believe is real. And the suggestions are that the market might more than double or get up 3 times in the next 9 years. Emerging producers, I've suggested here 5 pegmatite and 1 brine. So this excludes people who are already in production, the big guys who are going to be adding on incrementally. Not all graphite deposits are created equal. The same thing as the pegmatites. There's big variation between them, different processing required in different markets. Global production, 1.2 million tons, and this is only natural graphite. Dominated by production of graphite from flake graphite from schist and gneiss metamorphic rocks. That's 70%. Many producers, but dominated by 2 countries, China and Brazil. And whatever people say about China running out of graphite, I don't see that happening in a hurry. The Chinese have an amazing ability to get things happening. But maybe they don't have all the big flakes. Graphite markets, 1 dominant market, refractories and steel, which is declining. Batteries, fire retardant, and building insulation are all growing or hope to grow in future. And the flake graphite market, I think, might grow by 2025 by 50% to 1.2 million tons if these various predictions about batteries and buildings, construction stuff happens. And emerging producers, I've just taken some countries, Canada, Madagascar, Mozambique, and Tanzania, who could bring about 800,000 tons a year onto the market. And thank you very much to the AIG, to CSI Global, and to Industrial Minerals Magazine.